Okay, this screencast covers eclipses. This screencast accompanies my lecture on this topic. Okay, we'll begin with the solar eclipse. The solar eclipse occurs during new moon when the moon passes in between the sun and the earth, and then therefore the shadow that is cast by the moon falls onto the surface of the earth. Okay, definitely not to scale. This graphic here depicts the basic geometry of the solar eclipse. So for example, you first of all have sunlight coming from the top of the sun, passing by the top of the moon like so. And then you have sunlight coming from the bottom of the sun, passing by the bottom of the moon like so. This then in 3 dimensions creates a very distinct cone-shaped shadow called the umbra. Notice that the umbra here lies on the surface of the earth. So if you happen to be one of the lucky ones, that is, if you are standing in what is called the path of totality, then the umbra will reach your location, and then therefore you will see a total solar eclipse. The sun will completely be covered up by the moon. However, there is also a less distinct shadow here and here to the side. These are referred to as the penumbra, and the penumbra are formed in the following way. So you have sunlight here coming from the top of the sun and then passing by the bottom of the moon like so. Sunlight from the bottom of the sun passing by the top of the moon like so, creating these less distinct penumbral shadows. So if you happen to be standing right here on the surface of the earth where the penumbra is located, you will then see a partial solar eclipse, so only a portion of the moon is covering up the sun. Now in my lecture on eclipses, I go through all of the startling effects that you would see if you lie in the path of totality. In other words, you're one of the lucky ones and you'll see a total solar eclipse. Let me go ahead and show you some pictures of solar eclipses. Okay, here's a nice time-lapse composite photograph of an entire total solar eclipse from the onset of the partial phase, which begins down here, through totality here, and then out the other side of the partial phase over here. Total amount of time from basically one side of the photograph here to the other is a couple of hours. Okay, the person who took this photograph basically exposed the same piece of film over and over, basically photographing the sun perhaps 10 minutes apart or so, from once again the beginning of partial here to the end of partial over here. Okay, I took this photograph. I took this photograph using a filter on my telescope during a partial solar eclipse that occurred in May of 2012. It was visible from here in Los Angeles. At the deepest portion of the partial eclipse, the moon is covering up about 80% or so of the sun. Okay, this is a photograph of just before totality occurs during a total solar eclipse. This is called the diamond ring effect for rather obvious reasons. You're looking at here the last little bit of sunlight peeking around the edge of the moon, resulting in the diamond ring effect as it's called. You can also see during this portion of the eclipse and into totality what is called the sun's corona. The sun's corona is the outer atmosphere of the sun. It is always there, but you're never going to see it during normal daylight hours because the surface of the sun itself is about 1,000,000 times brighter than the corona. Okay, this is another diamond ring effect photograph, but the photographer in this particular case was also able to capture some solar prominences here and here and here, for example, in the photograph. Solar prominences are magnetic storms on the surface of the sun. They are actually larger than the Earth. And when you look at the prominences using a telescope, so it's under magnification during the total phase of the eclipse, it is safe to do so, you can actually see the prominences moving in real time. You start to really get an understanding that the sun's surface is quite violent when you see the prominences in this manner. Okay, here's a nice composite of where each individual photograph was just taken a couple of seconds apart or so, right at the onset of totality here on the right-hand side of the photos. So you're starting to see here, once again, the diamond ring effect, but then as the last little bits of sunlight start to peek through valleys on the surface of the moon, you can then see for just a split second what is sometimes referred to here as Bailey's beads. Right as totality occurs, you'll also be able to see for a brief moment this pink layer here of the sun's atmosphere called the chromosphere. This pink layer of the sun's atmosphere is always there, but once again, you're never going to be able to see it during normal daylight hours. Hey, here's a nice photograph of totality. When you look at the moon in this manner, no light is coming from the moon at all, so then therefore the moon appears rather completely black when you see it in this manner during the total phase of the eclipse. Once again, here's the corona. Okay, this is a photograph of the surface of the Earth while the total solar eclipse is happening. You can see right here the umbra, the shadow that is being cast by the moon falling onto the surface of the Earth. Okay, the umbra itself is less than 100 miles wide, and it's basically racing across the surface of the Earth at a speed of around 1,000 miles per hour or so. So for this reason, you're only going to be able to see a total solar eclipse for a couple of minutes as the umbra passes over you. It takes a couple of hours for the umbra to move basically from one side of the Earth's disk to the other. Okay, now the next total solar eclipse visible in the United States occurs on Monday, April 8th, 2024. On that day, I will be right here in the path of totality in southern Texas. So far in my lifetime, I've seen 3 total solar eclipses. I hope to get 1 or 2 more in the remainder of my life over the course of the next couple of decades. I highly encourage you to see a total solar eclipse sometime during your lifetime. It is perhaps the most spectacular sight in nature. Okay, next is the annular eclipse, which is also a type of solar eclipse, so it occurs during new moon, but the moon's orbit about the Earth is not a perfect circle, instead it's elliptical. So then therefore, if the geometry is just right during new moon for a total solar eclipse to occur, but the moon is at its furthest point in its elliptical orbit, this then means that the moon does not quite cover up the sun. So you then see a ring of sunlight like so around the moon. Therefore, this is referred to as an annular eclipse for that reason. The word annulus, by the way, is the mathematical word for ring. Now, during total annularity, if you will, the sun itself is still too bright to look at with unprotected vision, so you don't get all the spectacular effects of the total solar eclipse that I mentioned earlier and I also describe in the lecture. Annular eclipses are a little bit rarer than ordinary total solar eclipses, and they do have a beauty in their own right. Take a look at the difference here in the geometry of the umbra that is created when the moon is a little bit further away in its orbit than during an ordinary total solar eclipse. Notice that the umbra itself, the bottom portion of it, is actually above the surface of the Earth. So then therefore, if you were standing right here on the surface of the Earth, this is then what you would see. Okay, so here are some photographs then of annular eclipses. Okay, this is a nice composite shot here. The person who took this photograph used a filter on their telescope to safely look at the moon covering up the sun. But as you can see, during the annular phase, it doesn't quite cover up the sun, and you end up here with this ring of sunlight. Here's a spectacular annular shot taken during sunset. This was actually during that eclipse that I mentioned earlier of May 2012. It was a partial, as seen from here in Los Angeles, but the eclipse itself actually wasn't a total solar. Instead, it was an annular. Okay, this photograph of the exact same annular eclipse, it was May 20th of 2012, by the way. Actually, this photograph won a prize for National Geographic magazine. This is a picture of the Horseshoe Bend area of the Grand Canyon, and you have a nice composite picture here of the annular eclipse to sunset. Okay, the next annular eclipse visible in the United States occurs about 6 months prior to the next total solar eclipse. This will occur on Saturday, October 14th, 2023. Once again, the path of annularity passes through southern Texas. I'm going to be there on that day. Okay, next is the lunar eclipse. The lunar eclipse occurs during full moon, when the moon then passes into the shadow that is cast by the Earth. So you then once again have the formation of the umbra and the penumbra like so, but in this case it is the Earth that is in between the sun and the moon. All of this occurs during full moon. Once again, however, this geometry here is definitely not to scale. It takes the moon a total of a couple of hours to move from one side of the diagram to the other like so. Once again, this is all occurring during the total phase. So because the lunar eclipse occurs slowly, you could take your time to appreciate it. You could appreciate all of the subtleties as they slowly occur, unlike the total solar eclipse where everything seems to happen all at once. Notice that you just essentially have to be here on the night side of the Earth in order to be able to see a total lunar eclipse. Okay, here's the penumbral phase of the lunar eclipse. This is while the moon is passing through the Earth's penumbra. When it does, you're really not going to notice much difference between this and ordinary full moon, but the moon will be a little bit dimmer than it would be during ordinary full moon. And as the moon passes deeper and deeper into the Earth's penumbra, it starts to take on a definite three-dimensional appearance. The reason for that is because unlike ordinary full moon, where basically the sunlight is striking it head on, in this particular case, during the penumbral phase, the sunlight is striking the moon somewhat from the side. Okay, this photograph here, which I took, by the way, is a couple of minutes after the previous photograph. This is when the partial phase of the lunar eclipse begins. So this portion of the moon here is still in the penumbra, but now this portion of the moon here is starting to pass into the umbra, like so. And then you can see the beginnings of the umbral shadow that is being cast by the Earth right here in the photo. Okay, here's a nice picture of basically the onset of totality. This is more or less when the moon is within the Earth's umbra, and as the moon passes through the Earth's umbra, you will begin to notice that it takes on a definite reddish appearance and color. And the reason for that is because when sunlight passes through the Earth's atmosphere, it refracts a little bit, it bends a little bit, and it then strikes the moon. It reflects off the moon, then to your eye. So when you look at the moon and it takes on this colored appearance during the total phase of a lunar eclipse, you're basically looking at the entire world's combined sunrises and sunsets. Okay, here's a nice picture of totality. The middle of the umbra is basically up here towards the top of the photograph. If the moon was actually dead center in the middle of the umbra, no sunlight would strike it whatsoever, and then therefore would actually be completely black. Here's a nice composite picture that starts to give you an idea of the size of the Earth's umbra that is being cast. This photograph here, and in particular, this one right here, you can begin to see that the Earth's umbra is a little bit around 3 lunar diameters in size. It takes the moon about 45 minutes or so to move from one side of the umbra to the other during the total phase of the lunar eclipse. Here's another really striking composite photograph. Each individual photograph of the moon here, from penumbral phase to partial to totality, each one of these photographs was taken just a couple of minutes apart. This bluish color right here as totality begins is sometimes visible as sunlight passes through the upper reaches of the Earth's atmosphere and strikes the moon. Okay, the next lunar eclipse that's visible in Los Angeles is not going to occur until Wednesday, May 26th of 2021. That's basically at the end of the next school year, after which I'm recording this screencast. Mid-eclipse won't be until just before dawn, however, at 4:18 in the morning. So you're going to have to get up pretty early in order to be able to see it. Okay, that concludes this screencast here covering eclipses.